Volcano, Chapter 2, The Big Blast. The May 18 eruption began with an earthquake that triggered an avalanche. At 8:32 a.m., instruments that were miles away registered a strong earthquake. The pilot and passengers of a small plane saw the north side of the mountain rippling and churning. Shaken by the quake, the bulge was tearing loose. It began to slide in a huge avalanche that carried along rock ripped from deep inside Mount St. Helens. The avalanche tore open the mountain. A scalding blast shot sideways out of the opening. It was a blast of steam from water heated by rising magma. Normally, water cannot be heated beyond its boiling point, which is 212 degrees Fahrenheit at sea level. At boiling point, water turns to a gas, which we call steam. But if water is kept under pressure, it can be heated far beyond its boiling point and still stay liquid. That is how a pressure cooker works. If the pressure is removed, this superheated water suddenly turns or flashes to steam. As steam, it takes up much more room. It expands. The sudden change to steam can cause an explosion. Before the eruption, Mount St. Helens was like a giant pressure cooker. The rock inside held superheated water. The water stayed liquid because it was under great pressure, sealed in the mountain. See it there. At 8:32 on the morning of May 18th, 1980, an earthquake triggered an avalanche that tore open the volcano and unleashed a searing blast of steam and rock. When the mountain was torn open, the pressure was suddenly relieved. The superheated water flashed to steam, expanding violently. It shattered rock inside the mountain and exploded out of the opening, traveling at speeds up to 200 miles an hour. The blast flattened whole forests of 180-foot-high firs. It snapped off or uprooted the trees, scattering the trunks as if they were straws. At first, this damage was puzzling. A wind of 200 miles an hour was not strong enough to level forests of giant trees. The explanation geologists later discovered was that the wind carried rocks ranging in size from grains of sand to blocks as big as cars. As the blast roared out of the volcano, it swept up and carried along the rock it had shattered. The result was what one geologist described as a stone wind. It was a wind of steam and rocks traveling at high speed. The rocks gave blasts its great force. Before it, trees snapped and fell. Their stumps looked as if they had been sandblasted. The wind of stone rushed on. It stripped bark and branches from trees and uprooted them, leveling 150 square miles of countryside. At the edge of this area, other trees were left standing, but the heat of the blast scorched and killed them. It says the blast leveled whole forests of huge firs. The tiny figures of two scientists on the lower right give an idea of scale. So you can't see it so well here. So let me see if I can't move this. There are the people. Shredded stumps looked as if they had been sandblasted. Outside the blast zone, surviving trees were covered with ash that lasted for months. The stone wind was traveling so fast that it overtook and passed the avalanche. On its path was Spirit Lake, one of the most beautiful lakes in the Cascades. The blast stripped the trees from the slopes surrounding the lake and moved on. Meanwhile, the avalanche had hit a ridge and split. One part of it poured into Spirit Lake, adding a 180-foot layer of rock and dirt on the bottom of the lake. The slide of avalanche into the lake forced the water out. The water sloshed up the slopes and fell back into the lake. With it came thousands of trees, felled by the blast. The main part of the avalanche swept down the valley of the North Fork of the Toutle River. There, in the valley, most of the avalanche slowed and stopped. It covered 24 square miles and averaged 150 feet thick. The blast itself continued for 10 to 15 minutes, then stopped. Minutes later, Mount St. Helens began to erupt upwards. A dark column of ash and ground-up rock rose miles into the sky. Winds blew the ash eastward. Lightning flashed in the ash cloud and started forest fires. In Yakima, Washington, some 80 miles away, the sky turned so dark that street lights went on at noon. Let's take a look back here at the pictures. So, material from the avalanche that poured into Spirit Lake can be seen in the foreground of this photograph. Some of the trees that washed into the lake can be seen on the far side. Mount Rainier, another Cascade volcano, is in the background. A gigantic column of ash and gas rose miles into the sky. Okay. Picking up now with ash. Ash fell like snow that would not melt. This eruption continued for 9 hours. Shortly after noon, the color of the ash column changed. It became lighter, a sign that the volcano was now throwing out mostly new magma. Until then, much of the ash had been made of old rock. At the same time, the volcano began giving off huge flows of pumice and ash. The material was very hot, with temperatures of about 1,000 degrees Fahrenheit, and it traveled down the mountain at speeds of 100 miles an hour. The flows went on until 5:30 in the afternoon. They formed a wedge-shaped plain of pumice on the side of the mountain. 2 weeks later, temperatures in the pumice were still 780 degrees. It says hot flows of pumice and ash also occurred during small eruptions in the summer and fall of 1980. Start with this picture here. An eruption on March 19th, 1982, melted snow and caused this mud flow. The smaller part of the flow went into Spirit Lake on the lower left, while the larger part traveled down the Toutle River. Finally, there were the mud flows, which started when the heat from the blast melted ice and snow on the mountaintop. The water mixed with ash, pumice, ground-up rock, and dirt and rocks of the avalanche. The result was a thick mixture that was like wet concrete, a mud flow. The mud flows traveled fast, scoring the landscape and sweeping down the slopes into river valleys. Together, their speeds and thickness did great damage. The largest mud flow was made of avalanche material from the valley of the North Fork of the Toutle River. It churned down the river valley, tearing out steel bridges, ripping houses apart, picking up boulders, and trucks and carrying them along. Miles away, it choked the Cowlitz River and blocked shipping channels in the Columbia River. When the sun rose on May 19th, it showed a greatly changed St. Helens. The mountain was 1,300 feet shorter than it had been the morning before. Most of the old top had slid down the mountain in the avalanche. The rest had erupted out as shattered rock. Geologists later figured that the volcano had lost 3/4 of a cubic mile of old rock. The north side of the mountain had changed from a green and lovely slope to a fan-shaped wasteland. At the top of Mount St. Helens was a big new crater with the shape of a horseshoe. Inside the crater was a vent, the opening through which rock and gases erupted from time to time over the next several years. It says, in depth of the May 18, 1980 mud flow can be seen in traces it left on the trees along the muddy river. The mud flows roared through the logging camp, overturning large pieces of equipment. It swept up and carried along huge boulders and tore out bridges. See this before and after pictures. So before and then after. Looks completely different. And down the bottom here it says, on May 17, 1980, Mount St. Helens, as seen from Coldwater 2, had a soaring, ash-strained peak and green forest climbing its slopes. The next day, the big eruption tore the top of the mountain and flattened the forest, as shown in the September 9, 1980 photograph taken from the same place at Coldwater 2. Boot Lake before and after the eruption. In 1980, St. Helens erupted 6 more times. Most of these eruptions were explosive. Ash soared into the air. Pumice swept down the north side of the mountain. In the eruptions of June and August, thick, pasty lava oozed out of the vent and built a dome. It's caption here. In May 1983, the dome was huge. Note the size of the two scientists lower left standing on the crater floor beside the dome. Okay. Now it says, but both domes were destroyed by the next eruptions. In October, the pattern changed. The explosion stopped, and thick lava built a dome that was not destroyed. Later eruptions added to the dome, making it bigger and bigger. During this time, geologists were learning to read the clues found before eruptions. They learned to predict what St. Helens was going to do. Their predictions helped to protect people who were on and near the mountain. Here it says, the crack in the dome shows a red-hot molten rock just below the surface. To learn what the volcano may do, scientists make many kinds of measurements, trying to follow the movements of magma inside Mount St. Helens. Many are made inside the crater. In this photograph, scientists can be seen in the lower left. The dome is to the right, the crater wall to the left. With his instruments shielded from the sun, this geologist is measuring the dome. Swelling may be a sign an eruption is building up. When magma moves, it causes earthquakes. These scientists are installing a seismometer, which senses earthquakes. Scientists also sample the gases given off by magma. A sharp increase of sulfur dioxide often tells of a coming eruption. In 1982, Congress set aside 110,000 acres around the volcano as the Mount St. Helens National Volcanic Monument. Outside the monument, bulldozers could clean up the forest be replanted. Inside the monument, little was to be changed so that scientists could study what had happened and was happening at Mount St. Helens, and so that visitors of all ages could see the effects of the eruption and return of life. Among these people were many natural scientists. They had come to look for survivors, for plants and animals that had lived through the eruption. They had come to look for colonizers, for plants and animals that would move in. Mount St. Helens had erupted many times before. Each time, life had returned. Now, scientists would have the chance to see how it did. They would see how nature healed itself.